Hi everyone, welcome to my stream. Uh, so today today's topic is to have some kind of memory compaction for my voxel game. So the problem currently is when we generate this this command the terrain chunks. we are doing some we are doing something like that. So if it is empty chunk, then we don't put them into our vertex cache, otherwise we put them. But still we are wasting a lot of memories. We can, if we do some printing here, oh hi, uh yeah. Oops, that's not very nice. Let me do this. I changed some of my OBS settings. Hopefully my audio will be better, but let's see. There are a lot of vertex count 0. Let's get rid of that, because we guard it against empty chunks now. I just want to mention I changed some of my OBS settings, so hopefully my audio will be better. If I still have audio problems, or if my audio become better, please give me some feedback. And you can see we allocated a lot of memory. Most of them are unused. And as a result, if we want to allocate, let's say, currently we are wasting like 50 megabytes for per chunk, and then on average we use less than 1 megabyte. If we allocate 100 chunks, then we are using like 1.5 gigabytes of memory. And that's not, the audio seems all right for me. That's good to hear. Yeah. So this is not acceptable. Maybe later, if we want to add some terrain editing, then we can do this kind of things because it is fast. But once the terrain are in a static status, we don't want to change them anymore, this become not acceptable. So instead, what we will do is we will still do the same kind of thing at here. until this point, but at this point, since we have a vertex count, we will just allocate another buffer according to the vertex count, and then you use that buffer instead of what we are doing here. So I think what we will do is we will have a persistent buffer vertex something like that. I don't have a better name for that. Maybe that sounds a little bit better. So here we allocated the vertex buffer but instead we will just have a persistent scratch buffer. Which is still 15 megabytes, but that is just one buffer. So we just have this one buffer, and later maybe we will have multiple scratch buffers. But this buffer is stored in the chunk manager, and the chunk manager needs to destroy that. Let's add something here. Because once we unmap, we can basically not use this data anymore. Maybe it's a good idea to wrap it in some way. Let's do that. And now at here, what we will do is to allocate another buffer. First, if is empty chunk, we still need to destroy that indirect buffer that we allocate on the fly. What? And we can just return. Else, we need to have another command to we basically need another buffer to actually hold the vertices. That we can use it here. And the scratch buffer will not used as a vertex buffer anymore, since that's only used in the compute shader. What else I haven't done? Yeah, that's about right. Now we can actually allocate this vertex buffer according to the information we have. So we will do the same kind of dance here. The usage will be vertex buffer bit. Later, if we want to add some GPU calling, then maybe we need to add a storage buffer bit. Let's print FMT format. That sounds about right, even though our buffer is currently empty. So if we just draw, yeah, we just see nothing. So The next step is to have another command that we have the exactly same kind of thing at here, even though it's probably a better idea to simplify it somewhat. To just reduce the duplication of the code, but I will do it later. Command buffer, this to meshing. This will be transfer command buffer, transfer we don't need to reset command pool at here, but instead at here. We can probably reuse this fence, so we can wait for fence at here. Or maybe it's a better idea to make the fence already in the signaled state and wait at the top. But yeah. So begin command buffer and forget to change this one. Maybe it's a good idea to change this into, well, I guess this is exactly the same, so you get rid of this and add here, which we do is command copy buffer from our scratch buffer into the destination vertex buffer. Command source buffer. source buffer is the destination is vertex buffer. Now we first need to have our command buffer. The next is region count and region. So region count is 1. We need a BK buffer copy struct. Where the source offset will be 0, destination offset will be 0, and the size will be size will be the size of the vertex buffer, and we can do it here. It is void, so we don't need to check anything. And I think that's good. Even though this is also the same as the previous. We need some additional usage flags for those buffers instead of not here. Where is our scratch? Yeah, instead of use as storage, we also it is the transfer source, and for our vertex buffer. Where we allocate our vertex buffer. We have transfer destination. That is not what I expected. My guess is those. Oh, I haven't submitted anything. So we haven't submitted anything. So as a result, we are just waiting for those fences to arrive forever. Yeah. Oh. Everything looks good, except we have a lot of validation errors. We still need to add the name for those command buffers, which is a good idea where we create a command buffer. Currently, I haven't implemented a wrapper for the command buffer, so let's just. Oh, we already have this debug util. We'll just use this directly. What we okay, it looks the same. I have this helper function because in Vulkan to have a setup debug name, we need to set up this object, which feels a little bit redundant, especially for this struct type. So this is one, and we have another command buffer somewhere. It's here. Now we should have slightly better error message. It is all the transfer stuff. So we create our command buffer in the wrong queue because our command pool is for the compute pool. You know what? I will just use compute pool for here to make things a little bit easier. Later we will probably change that. So I think we are basically good now to just have some tracks. This is 10, 100, 10 times 10, 100. It's like 1,000 chunk or something. But if everything is good, we are using way less memory. We should be able to deal with this. Well, maybe 50 is too much. Let's say. Also, it will take a long time to generate. That's too long. Even though our memory doesn't seem to explode, which is good. If we do 20 though. Probably not the best utility of my time, so let's stop that. But anyway, because we don't have asynchronous loading of trunks yet, it's hard to say we load a large number of trunks. But anyway, we should have we should have way less waste of memories. So let's commit that. No, not here. And another observation we have is that we don't need our indirect buffer anymore, because the size of our the size of our the size of our vertex buffer will be exactly the final size we want, so we can just use wait, we probably still need indirect buffer because yeah, we don't need it anymore, sorry. So instead of have an indirect buffer here, we can just have a size. And then For here, we can just use vertex buffer size. We need to delete that index buffer somewhere. First, not here. We can have one indirect buffer. Oh, it's not really indirect buffer anymore. It's just a buffer for holding the vertices count. But let's call it indirect anyway, at least for now. Where we create our indirect buffer, we don't need to create it here. Oh, sorry. We don't really need to. Probably it's still a better idea to do this. This way we have an indirect buffer. Which is not really indirect, so we will change its name before we commit. But let's do it for now. Also, let's get rid. Let's set this back to 0, so we can use it the next time. We don't need to destroy the indirect buffer. Instead, we destroy it here. This side looks good. For this side, we don't need to do any indirect drawing. So it will be just vk command draw without indirect. Oh, it's instance count first vertex. Size is not a best name. Maybe we should call it vertex count. What are you doing? This is not very helpful. So I tried to use the refactor tool for C line and it's just stuck. How to stop this? That is definitely not right. And it does not get the correct result. This should not be vertex buffer size though. The vertex count. Everything looks fine. We don't have holes or some weird stuff. Everything looks okay. Let's change the name of that indirect buffer because it's not really indirect buffer anymore. And we probably don't need that large of so we can get away with only one field. Let's call it what should we call it? This buffer accumulates vertex count. That's a really poor name, but I don't know what to call it. Oh, we can put it in the alt buffer. But our alt buffer is currently GPU only, so that's probably will not work. I think this will. Maybe let's get rid of this indirect and this buffer name whatever, it doesn't really matter. And if we do this, then when we allocate this buffer, we don't even need that much, but instead just one in where we do our map stuff. Well, let's see instead have just have a private struct maybe. Where this struct will only have one field. We can probably just do this here like this. And when we do our map, we can do this. Everything should still be the same. Yep, everything is still the same. Maybe accumulated is a bit long. Let's change it to reduced. And here also. We already deleted the indirect bit, so I think that's good. that looks okay, and we are done with our goal of performing memory compaction. But let's maybe make the change of we don't need to wait for fence at here, but instead we wait for the fence when we can before our next submit. But then what we need to do is when we create our fence, it's a lot of stuff we created. We need to explicitly say that the fence initially is signaled. That's the order wrong. That looks good. Doesn't like it. Why it doesn't like it? I said the fence status is initially signaled when we load the chunk, it should be signaled. Anyway, I can try to figure it out later. This is one thing, it's probably not our top priority because currently we are just waiting for one additional fence that doesn't really matter that much. I think the more important thing is to have a async trunk generation. So currently in this function we kind of block the CPU twice. Once in here we say, hey, wait for the meshing process to finish, and another is at here. We say, hey, wait for the fence to wait for the copying to finish, and both stages can be just synchronous on the CPU side. We can say do some meshing and then have a rest and do some after we after and then after CPU are sure that this meshing process is done, we can do the second copy, and then CPU can start to do some other stuff again. This will be much faster, but currently we don't have this infrastructure. So maybe after we implement infinite terrain loading, which I plan to be the thing we will implement next time, we can start to work on the asynchronous trunk loading. And for today, I just want to do some quick refactoring because this function gets ridiculously long and most of its stuff are quite redundant. I think this whole thing, right descriptor set stuff can be put into the class. So, but let me do it later. First, I want to address that this command recording, and we just start doing just ridiculously amount of stuff, and so now I will just do some refactoring. If you feel like it's boring, you can just stop watching it now. First, we will do the same thing of create a header. Let's just call it command buffer. Maybe it's a header source pair. Maybe let's just call it commands, and it will be command buffer and also command pool, those kind of stuff. So the first function we want is some kind of create command buffer that we can, or allocate command buffer. We can use them to and for allocate command buffer, what we really need is a command pool, a level, and a command buffer count. I guess command buffer count, let's ignore that for now. Just we can have another like allocate command buffers. Does a different function for that. Do you plan to use a thread pool? Yes, I do. Of course, using like stuff like just naked stir thread or stirred async is not very performant, so we need to use a thread pool. What am I doing? Okay, I changed the name to error handling. Don't care about count, so it's command pool level. I think we have something else that I missed. Oh, it's just command pool and level, so easy. So this will be my helper function to create command buffer. And what we can do here is just copy this code. We also need the debug stuff. Can't wait like all the compilers support bitcast, so I can get rid of this code. All this will be just be stirred bitcast. And command buffer allocate info. We allocate command buffer. But in here, instead of doing this, we need to do I think I have a helper function not here in the error handling. The helper macro, which will track the result. If result is not successful, we just return the bad stuff. So I think we can just do this. And that should be the command buffer, create command buffer code. And now if we include command here, we can replace this wall of code with let's give a level a default. So we should just care about primary. If we want secondary, we can explicitly say so. This is kind of thing that in C we cannot do, because C you cannot have default value for structs, but for struct members. But in C++ we can just do this. And for and we can delete all this wall of code. This is one place, and another place is at here. And with that, we can delete this code. Should still do the same thing. So if stud thread and stud async isn't very efficient, yeah, creating threads is very expensive. I'll probably just use TBB for simplicity reason. Also, that's something that my Beyond Core library does not have a thread pool yet. So I will just create one, and then later I can use it in my other project. And under the hood, it will probably just use TBB because that's easy for me. If you want to create those kind of things from scratch, there's a shell parent better code concurrency talk where he kind of goes through how to create a thread pool. Yeah, he calls it task system, but it's just a thread pool, and you can basically just put some lambda in it, and it will execute. So I will put in the chat. I will use TBB. Yeah, thanks. And this function doesn't simplify the code as much as I hope, but maybe we can use auto. It still doesn't really help. And certainly we simplify it somewhat because we don't need to like allocate info structs, and we don't need a separate code for creating debug stuff. So we can even get rid of this debug, even though it's still a lot of what? Oh, I also use this for when create compute pipeline, which I also need to refactor this. Why modified BMA? It's because I have a feeling that's because the IntelliJ messed up somewhat. Contents are identical. Okay. Then after that, I think the main thing that make this make this process painful is we have create this. We need to begin this and we add this and we submit it. So all of this can be probably just collapsed into one thing. I think in app we have a submit one. We have this immediate submit. But I don't want to wait the fences though. This function is not very flexible. Okay, I guess I will let me think about how to abstract this. So I will not do it now. Just that abstraction is too unflexible. That abstraction currently it's useful for like just transfer data, but for our terrain generation, I don't want to use that. For another thing is the whole right descriptors that we can put them into the class. So but if we put them into the class, we lose the size. But the size is fixed anyway. Let me just leave this as is, since if later we do need to use some like per computation data in the shader, this will be just inconvenient, but we can have helper functions. So do this. After the constructor, and this can be one. We can have another helper function called generate terrain mesh onto that scratch buffer. We call it generate trunk mesh. For generate trunk mesh, we do need the position of the chunk. Both should be private. Oh, we can use this transform. And then the next step is copy from copy mesh from scratch buffer. This gives us a vertex cache. Oh, I can just put this off. Oh, maybe not. There's kind of accidental similarity, so. And all of this can be put into here. Even that vertex buffer creation still needs a position. Also vertex count. Yeah, I forgot about that. not here. We don't have transform here. Oh. That will be. We can just calculate transform on the fly, I guess. It's not too expensive to calculating this. Everything looks good. This function gets significantly shorter except this part, which we will also abstract away. And for the transform, we can totally do this. This will be no discard, but it's private, so we can just say no discard here. And There's another place we use the here. So another part that gets really cumbersome is here. So we can totally make this lambda a member function. I think maybe later we can pass the scratch buffer into those functions. In the case we have multiple scratch buffers, yeah, maybe that's a better design. But let me do that first. No, I am happy with this function. It's pretty short and it's understandable. All the heavy stuff are in their own member functions. Yeah, just before commit, I want to, instead of doing what I am doing now, I want to pass the scratch buffer into. Um, oh, this is not. Maybe not. Let's just not do it now, and maybe we can do it later. And I think I'm happy with the current status. So next time we will just implement infinite terrain generation. So instead of generate terrain with a loop like this at the start time, we will dynamically load the chunks depending on our position. So thank you for watching and see you next time. Oh, hey, sorry, I just saw your comment and end the stream here. Yeah.